thought I'd do a quick video here on some harder hyperbola questions. And we've got one here, y equals 6 over 1 minus x minus 3. Probably haven't talked about it in class much the other day, but the 1 minus x situation, if the negative is in that denominator there, as opposed to a negative being in the numerator, that means we've got a reflection in the y-axis. So you recall that normal hyperbola is that. Okay, and if we reflect the hyperbola in the y-axis, okay, we get this situation here. Okay, so that's going to be the general shape of this graph because of that reflection in the y-axis. Okay, so what are our asymptotes? We've got 1 minus x there, and with the 1 minus x situation, we're looking at the value there of x, which is going to make the denominator equal 0, and that's the value of x equals 1. So that's where our asymptote is going to be. So let's put it there at x equals 1. Okay, so that's 1 there. We've got to shift down 3 places. So our horizontal asymptote is at y equals negative 3, which is there. And our general shape, as I said, is going to be reflected in the y-axis. So what are our intercepts? Well, if we go to the process now of finding those, if we make x equal 0, we get this. So that's going to equal 6 minus 3 equals 3. So our y-intercept in this case is going to be 3. There. Our x-intercept, let's get rid of that for a moment. Our x-intercept, we make y equals 0, so we get 0 equals 6 over 1 minus x take 3. Negative 3 goes to the other side and we get 6 over 1 minus x. Multiply the left by 1 minus x, we get 3 minus 3x equals 6. Take the 3 over to the other side, we get negative 3x equals 3, for x equals negative 1. So our x-intercept is going to be negative 1. Okay, so remember it's been reflected in the y-axis, so we're going to have one section of the graph down here in the bottom right hand corner, so just in here, and our other section of the graph will be around here like so. So that's the graph of 6 over 1 minus x take 3, reflection in the y-axis, and our asymptotes at positive 1 and negative 3. This next question is an interesting one. We've got a negative there and a negative there. So we've actually, in this situation, if we're looking at as far as reflections are concerned, we've actually got a reflection in the x-axis, which that negative gives us. Okay, that one there, asterisk next to it. The negative there up next to the numerator. So that actually gives us a reflection in the x-axis. So we get that and that. And then a negative down here actually then gives us a reflection in the y-axis, which actually takes us back to the same shape as normal. So what we've got there, if I write this question out again, is a double reflection situation for this graph. Now there's another way of going about this. This can actually equal the same thing as something else. Take for example, if you've got 4 take 6 over negative 3, okay, that's going to be negative 2 on negative 3, which is the same as 2/3. Take this fraction then and change the signs of everything. So negative 4 plus 6 over positive 3. Notice how two expressions are the same, except for I've changed the signs of everything. That equals 2 over 3, same thing. So what I can actually do here is take this part here and change the signs of everything. So it could actually equal, I'll leave the one where it is, plus 1 over x minus 2. And if we write the fraction component of that first, same as this. So if you're looking at doing one such as this, you can actually transform it to that, which is a little bit more familiar. And And that's why, I just mentioned we get the double reflection, and that's the orthodox shape, standard shape of the hyperbola before any reflections. Shift 2 places to the right, so a vertical asymptote at 2 and a shift 1 place up. So if you were to do that one, I think you might find it easier to actually change the question to 1 over x minus 2 plus 1. Remembering in a fraction, as I demonstrated, you can change the signs of everything and maintain the same expression. Let's have a look at this next question here. We've got 2 over 3 minus 4x minus 1. And we've got a negative down here in the denominator, which means we're going to get a reflection in the y-axis. And just repeating that because I don't think in my original video I mentioned that the y-axis reflection. So that's why I'm doing a couple of these now. Now let's just draw up the structure of this graph. Oops, sorry. Get a solid line. Let's draw up our axes here. Okay. Let's first of all look at what is going to be our vertical asymptote. Well, we've got this on the we've got this on the bottom here. 3 minus 4x. Now to find the vertical asymptote, what we really do here is make this equal to 0. So if I go 3 minus 4x equals 0, that means 3 equals 4x, x equals 3 on 4. So that's going to be our vertical asymptote. So let's draw that in at 3/4 down there. Let's label it there, 3 on 4. What's our horizontal asymptote? Well, we're moving the graph down 1 place because of the minus 1, so that's going to be down here at negative 1. Might just copy this over the next slide and we'll try and find our intercepts. Okay, so let's find our x-intercept first of all. So y equals 2 over 3 minus 4 times 0 minus 1 equals 2/3 minus 1 equals negative 1/3. So our y-intercept is going to be at negative 1/3, which is about there, say. Let's have a look at our x-intercept. Let's make y equals 0. Take 1 to the other side. Take negative 1, changes to positive 1. Multiply through by 3 minus 4x. So 3 minus 4x times 1 equals 3 minus 4x equals 2. Take the 4x to that side, we get positive 4x. Take the 2 over, we get 3 minus 2 equal 1. So x is going to be 1/4. So x equals 1/4. So our x-intercept's about there, 1 on 4. Just change pen colour so it's a bit easier to see. So our graph, remember, it was reflected in the y-axis, so it's going to be in the top left here and bottom right. So there's our graph. We'll have a dilation of 2, by the way. There's our graph of 2 over 3 minus 4x, take 1. Last question we'll look at in this video is y equals x plus 3 over x minus 2. And I've got a little light bulb there because these come up a fair bit. And what you've got to do first up here is get, they're hyperbolas by the way, but if you don't know what you're doing here, you'll try all sorts of weird and wonderful things, but what you've got to do is long division. So what we do is do long division, divide x minus 2 and x plus 3, and the resulting answer here will give us our graph in the form of a hyperbola. Okay, so let's start. X and x goes once, okay, and then we multiply through. 1 by x minus 2 is x minus 2. Subtract. 3 minus negative 2 is 3 plus 2 is 5. Okay, so our answer, that's our remainder. So answer is 1 remainder 5. 5. Remember that we can also write that as 1 plus the remainder over the expression we divided in the first place. We divided into our divisor there, x minus 2. So now that becomes the the hyperbola. Go back a step. The hyperbola that we graph. So that question there is effectively the same as that. So the light bulb is an expression like that. There's a couple in the book, and I've just done one of them. You've got to do the long division to convert it to that. Okay, and you should be able to draw that hyperbola from there. It's quite a straightforward one. That's the hard step, is remembering what to do when faced with that expression there. Once you know what you're doing and you can execute the long division, the actual hyperbola ends up being pretty easy to graph. Okay, that's it for now. So there's some harder hyperbola questions for you to look at.